All right, this next type of factoring that we're going to be doing is called a difference of two squares. So when we're looking at, and again, going through our rules of factoring, our first rule is always to factor out the greatest common factor. And in this problem that we have, there is no greatest common factor. So then we look to see how many terms we have. Just to kind of recap, remember, if you have 4 terms, we factor by grouping. If you have 3 terms, then you factor by trial and error or by product sum method. If you need to review any of those, you can go back and watch some of those videos also. Now in this case we have 2 terms. And when we have 2 terms, then we have to either be working with perfect squares or perfect cubes. Those are our only 2 choices. In this case, x squared and 9 are both perfect squares. So this is where we call factor using the difference of two squares formula. Now this is extremely important. You have to have only 2 terms for this to work, and they have to both be perfect squares, and they are being subtracted. That's that word difference of 2 squares. This only works when you've got a difference or a subtraction of 2 perfect squares. So let's look at this x squared minus 9. We have 2 perfect squares being subtracted. So in that case then we have a formula or a pattern that we follow. And it says, the pattern says, whatever you've got that's being squared minus the second item that's being squared will factor into your first plus your second times your first minus your second. Now, in order for us to see exactly what is A and B, we really need to have it in this proper form. So we really need to have it in the form of something being squared minus something being squared. So I like to write it out like this first. So what do I have to square in order to get x squared? Well, that would be an x. And what do I have to square in order to get 9? That would be a 3. That tells us that x is our A value and 3 is our B value. Once we can identify what is A and what is B, then we can use the formula to finish the factoring. The formula says that this will factor into A plus B, so in this case it would be x plus 3. And then the second factor is A minus B. So in this case that would be x minus 3. And this is the factorization of x squared minus 9. Now we look to this next problem. We have a perfect square. X squared is perfect square. 25 is also a perfect square. But what's the problem here? The problem here is this is a sum and not a difference. We do not have a formula for a sum, only a difference of 2 perfect squares. This is not factorable. It's not possible to do. Well, it will be later on, but we won't talk about that right now. This is not factorable. I say it's not, that it will be later on. That's not exactly true. There are ways that you're going to learn to solve things with methods other than factoring, but we'll get to that at another time. So this is not factorable. Do you remember what another word for things that are not factorable is? That would be called prime. So this sum of 2 squares is actually prime. We do not have a pattern to deal with this.